Hey students, today we're going to look at Sec 3 AMF on polynomials, on how we can use two methods to solve for the missing variables a, b, and c. Okay, so when two polynomials are equal, we can say the left-hand side and the right-hand side are equal. So there are two methods to which we can use to solve for a, b, and c. Okay, one method is called the substitution method. So method 1. Okay, substitution. So for this first method, we will attempt to sub in certain values of x in order for us to come up with certain equations that we can use to solve for a, b, and c. So maybe one thing we can try is to sub our x value as 1. Okay, because if you pick 1, that will allow us to get rid or eliminate some of the terms within our equation. So when x is 1, we can say that we have this will be equals to. Now notice that when x is 1, the term containing a will disappear because 1 minus 1 over here will give you a 0 for this term. So this whole term will disappear and you are left with just these two terms. So we have b bracket 1 minus 3 plus c. All right. So on this end, we'll have 20 minus 9 minus 29, negative 9. Right. So this can be our first equation. Of course, we can make c the subject. So we have c equals to negative 9 plus 2b as our equation. Okay. Now, maybe another value we can take is to let x be negative 3. So let's try that. This will also get rid of our first term with the a. So we have 5 bracket negative 3 square plus 15. First term is gone again. And here we will have negative 3 minus 3b plus c. So this will be 45 minus 45. Okay, tidying up, we will have negative 29 equals to negative 6b plus c. And now we can apply our substitution method. All right, we can replace our c using what we have over here. Okay. So by subbing it, we will have negative 39 equals to negative 6b plus negative 9 plus 2b. So expanding this, we have negative 29 equals to, okay, here we have negative 4b minus 9. By rearranging, 4b will be equals to 20, b will be equals to 5, which means that now we can sub the 5 into this, and that will allow us to obtain our c value as well. Okay, so c will be equals to negative 9 plus 2b. So c will be equals to 1. Okay, now that we have a and b, we are able to move a step further to solve for our a value. We can do that by first subbing in our c and b values first into our equation. Now, to find a, perhaps we can pick our x to be 0 next. 0 is a very useful term to use because it would allow our calculation to be easier because we'll be able to eliminate most of the terms containing x. So on the left side, we're just left with negative 29. And our a term is still unknown, but in the bracket we have negative 1 and 3. Now we know what b is. B is 5, so we have plus 5 bracket negative 3. Okay, and our c value is simply plus 1. Okay, so rearranging, we have negative 3a minus 15 plus 1, that will give us minus 14, 29. So 3a will be equals to 15 A will be equals to 5. And with that, we have found our 3 missing variables. So as much as we can, one advice would be to use whole numbers as your values as much as possible. And try to use values like 0 so that will greatly lessen our working and reduce the tendency of being careless. All right. So this is our method 1 by substitution method. Okay. So now we're going to try method 2. All right. I'm going to just draw a line here. Okay. So for method 2, it is called the comparison method. Okay. For the comparison method, we will expand everything on our right side. Okay. So I'm going to zoom out a bit. So by expanding the right-hand side, we will have, okay, let's try the left-hand side first. Copy and pasting of the left-hand side. Okay, we will have bracket AX minus A times X plus 3. Let's get rid of the first bracket first. Plus BX minus 3B plus C. Okay, we're also going to expand this bracket here. So we have AX squared plus 3AX minus AX minus 3A plus BX minus 3B plus C. So our next task is to group together and ensure that our right-hand side is able to attain a quadratic equation format. That means this whole right-hand side, we want it to be of this form, AX squared plus BX plus C, so that we're able to make comparison to the terms on our left side here. Okay, so let's do that. So by simplifying, this will be our only x squared term. We have quite a few x terms that contain x. So in the bracket, we have 3a minus a, okay, plus b, factorize out the x, and the remaining constant term is minus 3a minus 3b plus c. So now we are able to do our comparison of the left and the right side. So comparing the x squared term, okay, comparing the x squared term, we will have simply a equals to 5 because we are comparing this and this. Okay, so we have a equals to 5. Now next we will go on to compare our x term. So comparing our x term, we can see that 3a minus a plus b equals to 15. All right. And we got that by comparing positive 15 with this term over here. Okay, that's how we got this. And now we know what a is, right? A is simply 5. So here will be 2a. So it's 2 times 5 plus b equals to 15. So if we were to expand this, we will simply get b equals to 5 as well. Okay, b equals to 5 as well. And last but not least, we also have our constant term. Now that we know a and b, this becomes much easier for us, all right? So lastly, we'll just compare our final term here. Negative 29 with this term. Okay, this is comparing of the constant term. So we will have negative 29 equals to minus 3 times 5 because a is 5, we know that already. And minus b is also 5. Okay, plus c. So negative 29 equals to negative 30 plus c. So c will be equals to 1. All right, so here I've given you two methods and you do realize that the answers are the same, all right, for A and B if you check for the answers. So some pros and cons before we end today's session is that for method 1, the initial part is a bit easier because you're able to get rid of some terms, but the simultaneous equation part will be the more tedious portion of the working. Whereas for the comparison method, the initial part of expanding the brackets can be quite tedious, but once we go to the comparing portion of things, things will become a bit easier because we can simply equate the left and right terms to be equal. So it's an easier simultaneous to solve. All right. So two methods, decide how you want to approach, and depending on the question, either method could be more tedious or less tedious, depending on that. All right. So good to go. Do check out our products as usual. Our Sec 1, G3 and G2 guidebooks are actually both out in popular bookstore now. And also our Mastering AMM guidebook, as well as our social media, Facebook, Telegram, as well as Instagram. All right, so have a good week.